So today's going to be the episode 3 of Roadway Lingo, and what we're going to be talking about today is horizontal geometry. And what I want to start off first is talking about the word geometry. So the word geometry just means a measurement relative to the earth. So if we look at our number 1 here, tangent, a tangent is just a straight line that touches a curve but does not intersect. And this word comes from the Latin word that means touching. So I'm gonna come here and draw and show you a little example of what exactly a tangent is. So I'm gonna draw a circle here. And basically what a tangent is a line that approaches a circle and goes around and exits, right? So this part would be a tangent. It goes along the curve, and then there's another tangent. So this would be T1. This would be the second tangent. And then we would have an intersection here, which is called the point of intersection, or PI. And this point is called the PC, the point of curvature. And this here is called the PT, the point of tangency. And this is the basic, some basic terminology for horizontal geometry and related to tangents and curves. So the next topic is bearing, and the bearing is just the direction of the line. So if you see here, we have our northeast, south, and west, and our bearings are measured from either north or south. And I'll do a quick drawing to give another example other than these 45-degree examples. So if we have north, south, east, west. So how this bearing works is we're going to measure from the north, and let's say I want my line to be in 60 east. So that means that this angle here is 60 degrees. And that this direction is traveling this way. Or this line is traveling this way. So, but if we were to draw the same line going the opposite direction, this way, then this angle is still 60, but it's not in 60 east. It's going to be south 60 west. So these angles are the same. The only thing that changes here is the direction. And here's the terminology for bearings, and that's degrees, minutes, and seconds. And these are the units that bearings reference. And to convert bearings to decimals, you divide the minutes by 60 and the seconds by 3600, and then you add the sum to the degrees. And here's an example here. It's a pretty easy conversion, and I'll explain. I'll show an example that clearly shows what exactly this is talking about. And the last topic is easting and northing, and these are just the x coordinates relative to the Earth. And this is all talking about the plan view. That's all that horizontal geometry is. It's in the plan view. So if I go to my OpenRoads file, then I can we can demonstrate this example here, and then I can show you the northing and easting, and we'll even discuss the tangent. So let's go to the OpenRoads. And here I have this line, and we can see it's at north 41 degrees, 20 minutes, 46.3 seconds east, right? So that means the line was drawn from the center, and then it goes out. And if I were to move this, then we see that the angle is measured from north. And if we go around, then we can see that if we go over here, then it is southwest, just like my demonstration before. And I want to type in this value and see if it gives me this, and it should. So let's test that out. So if I come here and just make sure that I type it with degrees, then we see that it's it did convert. And there's a little bit of rounding error here, because because this is a repeating decimal here, the 3. That's why there's a little bit. That's why it's not 30 seconds exactly. That's why it's 29.88. So now over here we have we have an example of a horizontal alignment, and as you can see, we have our point of tangency here, and then we have our point of curvature here. We have our point of intersection, then point of tangency again. So here would be the first tangent of this section. This would be the second tangent, and here's the third tangent. And we can check this information if we click on our geometry and then go to horizontal geometry report. And this will pop up, and we can see that here would be our first tangent, here would be our second tangent, and these are the coordinates of these of the point of curvature, point of intersection, point of tangency here. So let's take a look at this and see if we can use Civil Accutraw to kind of double check to make sure that this is giving us the right information. So if we look at this report and we see that this is the point of tangency here, and this is where the alignment starts, and if you see when we zoom in, our X, which is the easting, is 919.3099, and the Y, which is the northing, is 58.4896, which is what shows here. And if we were to come to the PC, point of curvature, then this information that we're seeing on our cursor matches exactly here. And that's it for today.